Okay, it's time to start the session. Building for the Next Billion by Neil Matthew. Please give a warm welcome to Neil Matthew.
Thank you. Before I start, I think I'll establish some credibility. My name is Neil Matthew. I work at Shuttle, which is an app-based bus service which picks people up near their homes and drops them to near their office, in which they can kind of enjoy journey without any driving, without traffic, with free Wi-Fi and AC. I've also worked on an application for farmers known as Gram Seva Kisan. It's won 2 national level competitions with Accenture and Yahoo's Innovation Jockeys 3 and Hash Open Data Apps Challenge by NASCOM and the Government of India. I've also been part of the Google Reach project, which tried to assess the digital literacy levels in India. And I'm hoping all of this kind of gives me some perspective to kind of help you go through this topic. First of all, what is the next billion users? That's the first question. The next billion users are basically the users who come online for the very first time via smartphones. And this doesn't just imply that this also talks about the kind of users that are coming online. They have a mobile-only mindset, and they have a demand for localized content. Their first language is not English. And if I give you some statistics, there's above 7.5 billion users right now, 7.5 billion people in the world right now. About 50% of that user base is actually internet users. And about 80% of developed countries, developed world are internet users. And about 40% of the developing world are internet users. So there's a lot of scope. There's a lot of people who have to come on board, but they're blocked in a way. And they're blocked because of these 3 barriers. So if you take a look at the image on the right, you'll notice the man of the match won 5 GB as his award. Now, South Africa has one of the most expensive internet packs in the world. But that kind of gives an idea of different countries have different rates, and data affordability is the first barrier. The second barrier is device affordability. Depending on how much you earn, can you afford a smartphone? And third, linguistic barriers. Like I mentioned, English isn't always the first language. So you kind of have to build an interface that they can understand. And that usually involves an interface that they can easily relate to. So Google has done a number of initiatives to kind of break down these barriers. A couple of initiatives are basically the Google Station. It's deployed in Mexico, Indonesia, and India. What it does is it actually offers free Wi-Fi services at a number of railway stations, which allows Indians to kind of come online for free. That's one. Also, the second barrier was device affordability. So Android One was an initiative by Google to kind of afford low entry, basically for low entry devices in the market. So Android One had one primary objective. Hardware manufacturers would not update your OSs on time. So Android fragmentation was kind of an issue which Android One kind of solved. They had tie-ups with certain hardware manufacturers to kind of offer them OS software updates, which kind of ensured that all of these users would get proper security patches and the latest Android version. And right now, with the introduction of Android Go, Android One is now focused only in the mid-range market, while Android Go is focused on the sub-entry level market, sub-$100 entry level market. Now, Android Go Android Go is a stripped down version of Android OS. It is designed to kind of optimize. It's designed for those 3 barriers. In a sense, there's 3 aspects here. One is the operating system. The operating system has a number of features catered to these users, one being the data saver feature, where you can actually block applications from running data when in the background. There are applications optimized especially for Android Go, which, for example, YouTube Go, Google Play Go. All these, again, have some compromises on the features, but they are around 5 to 10 MB of an APK. The 5 to 10 MB of APK has an APK size of around 5 to 10 MB. And basically, it works on the low-end devices. Finally, there's the Play Store. Now, this is relevant to developers because now if your application is optimized for Android Go edition devices, it comes up on top, while those that are not optimized are pushed down below, which is a good opportunity to kind of reach out to the emerging markets, because in this case, Google is actually on your side as opposed to those applications that have established itself. All right. Second, linguistic barriers. A number of initiatives are taken in the keyboard, in Gboard. It supports over 500 language varieties. It also has an AI-driven typing experience, which different keyboard layouts are available for different languages. It supports a hell of a number of languages, which means around over 90% of the user of the world can now communicate with each other using the Gboard. AI-driven typing interface here refers to the ability to predict text and autocorrect to make it more seamless while typing. And finally, you have voice assistant. So not everyone is comfortable with text. And because of that, there's a number of initiatives which allow you to speak to Google Assistant, and in Android Go, Google Chrome Go can actually read aloud text for you. So you can communicate directly with voice. Now, there are a number of case studies which have optimized applications for Android Go. I can talk about Uber Lite, I can talk about Flipkart, but I'm rather go and talk about ShareChat. But before I do, I think I have to establish some context. So a number of changes have happened in India over the last few years. One, smartphones are becoming more and more affordable, and data is becoming more and more affordable. Because of that, there's a higher penetration of internet users in India. The current stats is 500 million internet users. We have 75 to 80% who are using of that user base on mobile, and 200 to 300 million are regional language users, where English is not the first language. And looking at the growth, we can easily expect 1 billion internet users by 2020. Now, this is the target audience which ShareChat looked at. Now, there's a screenshot of a page on the app on the side. Do you notice anything missing? English. So this ShareChat knew their target audience well. They weren't looking at, so the two things they did, which I find very impressive, because that was their target audience, they don't have an iOS app. And they took out English completely. They knew exactly who they were focusing on. And because of that, this is now a homegrown rival to WhatsApp in India. Grew over the last few years. There were 50 million installations, and most of the content is user-generated. It's growing in itself. And it's also supported in 14 Indian language. Now, I'll be talking about the different building blocks which we can do, which we can use as Android developers. Now, if you open developer documentation, there is a vast number of things that you can, things you can kind of do. What I've done is I've just regrouped them into 3 parts and just chose a few tips and tricks that give you an idea what all tasks you can do. I've broken down to, so I've kind of related each block into a barrier. First one covers the first barrier of data connectivity. The second one, the barrier of device affordability. And the third one is linguistic barriers. So first, I'll kind of go through connectivity and data cost. Now, so I think it's important to kind of explain offline first architecture. The primary objective here is to kind of build an application that is offline first. What that means is when you need to retrieve data, it will look to your cache or your database for information. Only then will it make a request to the internet to load more information. So the idea is if you have an offline first application, it can run in airplane mode. There's incoming requests and outgoing requests. Incoming requests have to be cached as soon as they are made, and every time you make a second request, it loads it from database rather than making a secondary network call. Outgoing request, if the network is not available, cache the request until it connects to the internet and then resend that information. Now, I can give you some context. When I was talking to farmers and villagers in Kalchina, they don't have proper internet access. So like I mentioned before, I made an application for farmers, and all of them found them useful because so the application was very simple. All it did was load agricultural price information, where you can kind of check prices and in a sense, decide whether to sell it or stock it. You can kind of negotiate better with dealers. It was really small. All it did was kind of show information, show some prices, but it was very useful. But the problem is they don't always have data access, and smartphones were usually among the kids, not necessarily the people who've lived there for a long time. So what actually happens is there are about 300,000 telecenters across India, and each telecenter responsible for generation of government documents also has Wi-Fi access. So people from different villages will come to that telecenter, download the content that they need, and go back to their villages, which is where offline first becomes relevant. Now, the way to build this is extremely simple. There's a connectivity manager API, which tells you if you're running on Wi-Fi or mobile. How this is useful is you can kind of choose to let the user decide what content they want to download when they're on Wi-Fi or when they're on data network. And this is how you do it. There's a if condition, just load the connectivity manager. Second is fine-tune data transfer. This basically means that you want to be able to decide what the quality of your network connection is, and accordingly perform different tasks. For example, if you were downloading images, if it was on a low quality network, you would want to download lower resolution images. And Connectivity Manager and Telephony Manager gives you more information on kind of detecting what kind of network you want to run. For example, is active network metered? Lets you know whether your network is metered, meaning it is a data sensitive request. That can imply different things. It could be roaming, it could be battery consuming, it could be a large number of data. So this kind of helps you decide whether or not you want to run that, continue with that request immediately. Get network capabilities came after a while, and that also gives you an idea of whether it's on roaming. It gives you more information, whether the thing is on roaming, whether the network is congested, or again, if it's metered. So you can use this as well to kind of decide how you want to build the application. Second is optimizing images. Now, one easy thing you can kind of do, there's plenty of converters online and in Android Studio, is convert your JPG and PNG images to WebP. Offer similar quality for about the same compression. Same quality for a better compression. So WebP is one way to go, especially if you have an e-commerce application that downloads a lot of images. And second, use a caching strategy. Once you download an image, do not download it again. And there's a number of ways that you can implement this on your own, but one quick way is to kind of use the Picasso or Glide libraries. And I've given an example how you can do that. If you're making an application for a low-end phone, I highly recommend you skip the memory cache. It ends up giving you out-of-memory exceptions quite often. And when you're choosing a disk caching strategy, you can customize it depending on what you're trying to load. For example, if you can choose not to cache it at all, which is disk strategy none, or you can choose to cache everything. You can choose this cache strategy data, which means you want to download the original image. For example, let's say there's a high resolution image of 1000 into 1000 pixel. You download that, and then let's say in the application, you need to kind of render it into small thumbnails or smaller sizes throughout the application. So you can choose to cache the large image and not cache the smaller images that you might need throughout the application. Second, you can do disk cache strategy resource, where you only cache the resized images or whatever rendered image you like instead of the original image. So depending on what you want to do, you can use these components. You can also use vector drawables, but like I said, there's a lot of things you can do. These are just a few of the tips and tricks I personally find useful. Second is device compatibility and battery consumption. And to kind of explain this better, I'm going to compare two devices in India. One is the premium, the best-selling premium phone in India, which is the OnePlus 6. I've mentioned the price on top, which kind of gives you an idea why I call it premium. And second is the Nokia One, which is a low-end device that has Android Go edition. And I've kind of compared their specifications. If you compare OnePlus 6 and Nokia One, you'll notice a significant difference in display and resolution. So what most people do is, because they have big phones, they try to put a lot of UI content inside. But my advice is, if you're targeting Nokia One, kind of reduce the amount of information you want to show in one place. Allow them to scroll. Now, there's a number of ways in which you can kind of build your UI. You can use resizable layouts, but for screen sizes that small, I wouldn't recommend it. Instead, I'd rather you build a new layout completely for those devices. And one way to do that is using the small width qualifier. You can choose what the smallest width qualifier. You can choose at what density pixel, which level you want to build a design for, the UI for, and accordingly create a different layout using the usual Android way. And again, read more about it on the developer portal. But again, my objective is awareness. Second is processor, RAM, and storage. Now, what I'm trying to point out with the processor is, when you have a processor of this caliber, you kind of have to minimize the background task you're running. The more background tasks you're running in parallel, it slows down the application. So a couple of ways in which you can try to reduce the usages of services, try to rely on FCM more. RAM 8 GB, 1 GB, so the same thing kind of works out. And storage 128 GB and 8 GB. Now, what this implies is there isn't so much space on your device, and it becomes a competitive market. It becomes competitive, right? Every application has to kind of fight for their right to be on the user's device because they don't have that kind of space. So one example is JustDial is a local search engine in India where it offers you a way to search for movies, shopping, a number of things. And because they understood that customer pain point, they actually advertise, uninstall all the other apps, just install our app, because our app takes care of everything. So they kind of understood the pain point, they advertised in that direction. One app for movies, one app for shopping, one app for traveling. So this is, again, another pain point. Also, one of them is expandable, one is not. And that is important because by default, your application can only be installed on internal storage. Now, by default, it's internal only. But by setting it to auto or prefer external, you can kind of allow the user to push your application to the external storage, which kind of helps with this. There is some consequence to this action, though. If you kind of plug in your device to your computer and use mass storage, all your applications that were installed on the external memory card gets killed, which may cause breaking changes to your application. So you kind of weigh the pros and cons about this, but if you're targeting these users, it helps. At least you kind of earn some space or earn a way to kind of your way into their phones. Second, APK size. So one thing you can kind of do to kind of make this better is kind of reduce the APK size. Before, what we could do is basically generate different APKs for different configurations. It could be CPU architecture, screen sizes, languages, but this is no longer required with Android app bundles. Create a bundle. It's usually a few clicks if you're using the latest Android Studio. Release it to Google Play, which will distribute it in a way in which they'll generate the small APKs for you, the configuration APKs, depending on the configuration of the device. And if you want to take it one step further, there's dynamic feature, where you can kind of make your application modular and download only those features when the user requests for it. Second is Android Go. So if you want to build an APK specifically for Android Go, these are the 3 steps that you have to follow. One is targeting API level 26, which is pretty much a prerequisite right now. But it brought in a lot of advantages because it made a clean distinction between foreground applications and background applications. And by doing so, it ensured that background application doesn't consume too much battery or run too many requests in the background, and forces you to use something like Job Scheduler or Work Manager so that you can batch all the network requests together. So this was a huge step in the right direction. Second is using a higher version code in a non-Go edition. So you want to create different APKs that coexist. So this is one step that you have to do, release the Go edition with a higher version. And finally, you have to specify this line in the Android manifest that makes the application only accessible to, only available to RAMs with low memory, 512 to 1 GB RAM. And finally, battery. So I've used both of these devices to get a feel for what I'm dealing with. OnePlus 6 comes with a feature called turbocharging, which means I can charge my entire device in 20 minutes from 0 to 100%. Also, it usually lasts the whole day, and I'm not really concerned. The Nokia one requires multiple charges, drains really fast, and it takes 2 hours to kind of charge from 0 to 100, which is a significant pain point, which is why battery is important to users who are using Nokia one. And there are a couple of things you can do about it, but the main thing is try to minimize the activity of the application when in background. When it's in foreground, the customer is using it, you want to utilize whatever resource you have to the full potential to kind of give a good interface, provide an enjoyable experience for the user. But the moment it goes in background, what you can do is kind of minimize that activity. And that's one of the first steps. And this is also important in the sense that Google actually shows you a little pop-up that your app is draining battery. Do you want to force close it? Which is something you want to avoid. So I've mentioned an example of GCM Network Manager, but you're free to use Job Schedulers and Work Manager. In fact, GCM Network Manager uses Job Scheduler after a certain API version. One example here is basically you can choose whether to schedule one-off tasks or periodic tasks. You can choose to run those tasks which are aware of network activity, whether it's connected or not, or while it's charging. So all these steps can be kind of used. Also, if you're kind of optimizing your app, the first step is always identification. So I have a slide on Android Profiler, which is somewhat silly, but the objective is, if you have an emulator and you have let's say you have a list item, which has a title text view and a subtitle text view, and you end up switching the two when you're coding it. When you open up the emulator, you see the difference and you quickly rectify your mistake because you can see the difference, the mistake you made. That isn't visible when when you're talking about building battery optimized or performant applications. So if you can kind of get the hang of kind of using the Android Studio Profiler as you would an emulator, you can visually see the changes that need to be made as you develop your application. So I won't go into details, and I think there's one more talk on building performant applications in this Droid Kaigi. There's also another talk on Android Vitals. But another reason I'm mentioning this is the same thing. You want to identify what all is going wrong so you can fix it. And Android Vitals is one good way in which you can do that. It focuses on a couple of aspects. One is stability and performance. Stability here refers to ANRs and crashes. You can easily detect them, and you can resolve it accordingly. So these are the vitals. You talk about wake-ups. You want to minimize that as much as possible. That's also a reason for battery consumption. You can also measure other aspects like startup time. Your application should kind of start up within 5 seconds. It's one of the guidelines for building applications on Android Go. And like I said, these are just tools, and my objective is just to mention them. And I personally like Firebase Performance a lot. One of the main features of Firebase Performance is the traces. So you can measure a performance metric between 2 points in time. For example, you can measure the startup time of the application, but what I like Firebase Performance for mostly is the network request. The same app making the same request would take different times across different countries around the world. And you can actually see how those applications, how much time each application takes to download that content. And it gives you kind of an idea on how to cater to those countries or those devices. So it filters by device, OS, and country. You can also check what it's doing in the background and in the foreground, what all activity is there, and accordingly you can optimize it better. Finally, I have user interface and content. This caters to this, tries to fix the barrier of the linguistic barriers. Now, a little context. I told you I work in a company called Shuttle, which builds applications to kind of help people board the buses near their homes and reach their office. And they have two main applications, the consumer app and the driver app. The consumer app is what consumers would use to kind of book their bus, track their bus as it's coming towards them. The ETA keeps changing depending on the traffic, so they have real-time updates on where their bus is. But my main focus is the driver app. The driver app is what the drivers use to kind of ensure that they reach that point at a specific time, which is navigating the driver and the bus. One is boarding the customers. We use AQR, an audio QR code. It's kind of fun to listen to as you board the bus. And finally, sending GPS locations or pings or calling for assistance whenever required. Now, why this is relevant is when I make apps for the drivers, I have to factor in the fact that most of them are digitally illiterate. They've been given a phone for the first time, and they're trying to get used to that interface. So every time I make a small change, they get confused and they start calling the managers to kind of help them figure it out, which delays operations because consumers are dependent on the drivers coming at the right time. When we had to show permissions, runtime permissions, they were baffled. They didn't know what to do. So we had to actually show training videos, click allow 5 times or 3 times. And the only reason I grouped it up together was to kind of make it easy for them. But of course, information asking why they should do it in a specific way. So number of aspects that we had to add in the Android, so the number of aspects were there. One is we localized it for different drivers in different cities. 2, we made sure that the CTAs were highlighted significantly so that they know what to click. And also, most of them prefer audio over text. So we use the text-to-speech APIs. So if we talk about localization, if you focus on device locale, it's pretty straightforward. You kind of use a suffix .ja if you want Japanese or -hi if you want Hindi, and put the appropriate messages in the strings XML file. You can also do this for drawables too if you have different drawables for different different localized images. But and usually, if you want to just stick to device locales, that works. Everything is pretty much automated and taken care of by Google. But the moment you bring in an option to kind of allow a user to select a locale, there becomes a bit of a sync issue. For example, let's say the device locale is in English, but you allow the user to choose Malayalam, for example. the permissions would still show up in English. And that's something you have to kind of cater to. In fact, what I've done is kind of show the same language so that they don't get confused on the same page. Also, there's two kinds of content you want to localize. One is the content that's on your application, the static content, what labels you have in the text view, and one is the dynamic content. The content refers to error messages that come from the server or anything that you can't really save on the app. So you have to kind of manage that as well. And at one point, we had a feature request to kind of, we didn't want to launch a new application every time we introduce our application and our services to a new city. So we kind of shifted all the translations on backend and had it mapped using keys and values on the shared preferences and pull out whatever is appropriate. And also, a couple of other things you kind of focus on, for example, date formats. You have to ensure that you write the right locale there as well so that it's kind of translated. Again, these issues come up only when you're kind of focusing on user-selected locales rather than device. Second, text-to-speech API. This is very easy to use. And in fact, that snippet pretty much covers it all. You initialize this text-to-speech, and then you can check if that audio file is available for them. So you can set a language, let's say locale.us. If it's available, you can speak it. If not, you'll have to kind of skip it or do something else, or you can try to speak it, but it won't work. And you can choose options, like you can queue up all the translations you want to speak aloud, or you can have it so that it replaces the previous one. Now, one aspect you need to understand is so even though this support, right, depends on one, if that audio format file is available. The second aspect is basically you have to kind of go into the settings and download that information. So that's an additional step which needs to be done on if the consumers are within, if you can kind of help them out, that's good. But this is something you kind of have to factor in, that they download that audio format beforehand. Second, interactive UI. This slide seems a little generic, but it makes a big difference in the long run. Material UI is a standard that kind of works across ecosystems. And when people use the application for the first time, Android Go and a lot of applications are using Material UI, so it's easy for them to kind of get on board if your application uses Material UI too. I'm not talking about the specifics. I'm talking about components like navigation drawer, the floating action button. Make it simple so that you know what to click. Also, handle different error states properly. Because of low internet connectivity, you kind of have to make sure that they know when it's loading, know when there's an error state, know when it's empty. It's important to kind of let them know of all the states as they use your application so that they are not confused. At the same time, a button should be clickable. It should look like it's clickable, and that's pretty much easy with the Ripple, the following XML. You can kind of set your background to these two values, and it gives that effect. I've shown a small Jiffy above as well. And so to summarize, I talked about 3 barriers. I talked about network connectivity, the data affordability. I talked about device affordability, and I finally talked about linguistic barriers. These are a few of the steps that I've covered. And I call them my building blocks. Now build for the next billion. Thank you.